Welcome to this informative and concept-based video, the best for beginners who want to learn about negative exponents and reciprocals. Anil Kumar once again shares his passion of learning, 15 years of contribution with 20,000 YouTube videos almost daily being uploaded on the channel. Students globally are taking benefit. You can also join Anil Kumar classes. In this video, we'll discuss what are negative exponents and their relation with reciprocals. We'll go through some basic concepts. Write with negative exponents, write expressions with positive exponents, and then we'll have a worksheet with about 30 questions for you. The examples which I have taken here are quite a few. You will understand complete concept of working with negative exponents, simplifying expressions and evaluating them. Basically, a to the power of minus n is equal to 1 over a to the power of n. Once you understand, you can do questions listed here. Not only this, the worksheets which we are sharing with you are loaded with questions to practice, as you can see, right? So let's really begin with what these negative exponents are and how do we work with them. Here are some basic rules which you should know. Exponent rules, right? If you have the same base and if the powers are m and n and they are multiplied, then the exponents get added up. When you divide, then the exponents get subtracted, and when we have power of power, the exponents get multiplied. And that is the reciprocal we are talking about. A to the power of minus n will be 1 over n. If it is minus 1, then it is the reciprocal 1 over a. If we have a fraction like a over b to the power of minus n, then a and b flips, and you write this as b over a to the power of n. Remember, anything to the power of 0 is just 1. We'll prove it in this video also. If we have negative some number and square, it becomes positive, since square of a negative is positive. But if we have a cube, then it remains negative. Very important property. So once you understand these properties, you should be in a position to answer most of the questions related to exponents in general, correct? So let's begin with a very simple example where I'll actually show you how these exponent rules work. And the exercise is so designed that any student for whom even this subject is a starting point, this is the best video, correct? Well, in case you want to learn from me, you can always send an email on the address given. While those who watch our videos, they are on the success path, and Global Math Institute ensures that they do perform very well. Now, if you learn from us, you can be the best in your class.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Okay, so let's begin with a very simple example as shown here. We have 7 square over 7 cube. Now you know what square is. Powers means writing a number so many times multiplied, right? So it's a short way of writing. So 7 cube really means 7 times 7 times 7. Now definitely when you are dividing, you could simplify them, right? So you see one of them cancel, the other one also cancel. So what really remains is 1 over 7. You see 1 over 7. Now that is the result of 7 squared divided by 7 cubed. Now, if you apply the rules, let me remind you which rule I'm talking about. Now, if you have dividing, right, then the exponents get subtracted. Let's apply the rule now and see what happens. So, according to the rule, we get 7, 2 minus 3. And 2 minus 3 is minus 1. You get the idea. So, we have 7 to the power of minus 1 equals to 1 over 7. That is what we're talking about. How are negative exponents are related with reciprocals? You get the idea. So now we have a rule, and simply we could say that 7 to the power of minus 1 is basically equal to 1 over 7. Do you see that? So negative exponent and reciprocal, how are they related? Do you see that? Well, let's take another example just to check it out. You can also pause the video and see and verify the result. 3 to the power of 4 means we have 3 times 3 times 3 times 3. 4 of them, right? And 3 to the power of 5 means we'll multiply 3 by itself 5 times, correct? And clearly, we could again cancel 1 by 1. And if we do that, we are left with what? Well, just 1 over 3. And if you do this exponent thing, that is 3 to the power of 4 minus 5, you get 3 to the power of minus 1. Once again, we see that 3 to the power of minus 1 should be equal to 1 over 3. So, negative exponent with 1 is actually a reciprocal, right? Perfect. So, that is what we should understand. Simple. Now, here is another example. This time, what we have done is 2 to the power of 3 will means 3 2's, right? Multiplied with one another. 2 to the power of 5 will be 5 2's, correct? Now, if you cancel, 3 of them cancel. However, 5, we have 5 in the denominator, right? Not 4. So, it's power of 5. So, you have 1 over 2 times 2, okay? So, which is 4, right? You could also think about 1 over 2 square if you say, right? If you use the rule, what do you get? Well, if you use the rule, you get 2 to the power of 3 minus 5, and which is 2 to the power of minus 2. So, do you see that? Does it connect? 2 to the power of minus 2 is 1 over 2 square. So, once again, we see that the number flips, right, when the exponent is negative. Makes sense? I hope you understand this, right? Few more examples will help us understand better. So here are another set of examples. This time, let's work with 5 to the power of 3 and 5 to the power of 3. So when you divide, apply the rule. So 5 to the power of 3 minus 3 is 5 to the power of 0. Oh my God, I got 0 as an exponent. What does that mean? Okay, let's try to understand. What does that mean? Well, if we do the operation which we did in the last example, 5 cubed, 5 to the power of 3 is also said as 5 cubed divided by another 5 cubed. Okay, you are dividing the same number. All of them will cancel with one another. It really means 5 times 1 is 5, and this is equal to 1. Perfect. Well, that really means that 5 to the power of 0 is indeed equal to 1. Does it make sense? So, when the exponent is 0, in that case, what do we get? We get 1. Okay? So, let's try with the next example. So, the next example here is a to the power of 4 and a to the power of 4. So, well, a to the power of 4 minus 4, since we are dividing, but it also has a minus 1 index. This is the index or the exponent. But 4 minus 4 is 0, so we get a to the power of 0 to the power of minus 1. But anything to the power of 0 is 1. So we get 1 to the power of minus 1. Well, negative, we'll make it 1 over 1, reciprocal. But that is also 1, right? So we indeed get 1. So we see again that a to the power of 0 is also equal to 1. So that is a general expression, correct? And that's why the rule comes handy. So in the rule, we have written anything to the power of 0 is 1, correct? We also found that a to the power of minus 1 will be 1 over a. And if it was to the power of 2, 3, 4 or any other number for that matter, it will be 1 over a to the power of n. Does it make sense to you? So we have seen all these rules by now. Perfect. So let's continue. So we are done with this part. Let's take up the last example here. Can you tell me what is this number? 2a cubed divided by bcd, d to the power of 5 and everything to the power of 0. Well, you don't have to bother about it. We have an exponent of 0. So exponent of 0 clearly says that that should be equal to 1, since any number to the power of 0 is 1. So that is the rule, correct? And we have seen how it works, right? So with that concept, I think you understand both the things, which is negative and 0 exponents. Perfect. So in this particular exercise, you see how smoothly we are going through these examples. And then there will be worksheet loaded with questions, 30 of them coming your way. That will give you practice and understand this topic very well. Okay, let's move on. Here is another set of examples. I'd like you to pause the video this time and then answer these questions. Now, we have 2 squared divided by 2 to the power of 5 and everything to minus 2. So we have a negative exponents, correct? Now what should we do? Should we simplify inside and then evaluate? I think that is better. So the question here is simplify and then evaluate. So let's simplify first. Okay, so I could write this as equal to what? 2 to the power of 2 minus 5, right? 2 minus 5. And then we have an exponent of minus 2, okay? So 2 to the power of, let me write down first. Let me rewrite, okay. So we have 2 to the power of 2 minus 5 to the power of minus 2. Makes sense? Because it is division, right? So we applied the rule. So you have to subtract the index or the powers. So what do we get? We get 2 to the power of minus 3. And then we have minus 2 here. And when you multiply these two, what happens? 3 times 2 is 6. And negative times negative is positive. So we get 2 to the power of 6. So that is how you could simplify it. Now what is 2 to the power of 6? It is 64. Okay, so we get 64 as our answer. Does it make sense to you, right? So first thing we did was we applied the rule, and that is when you are dividing, right, in that case the exponents get subtracted. So we simplified using that rule, right? So because you're dividing 2 to the power of 2 by 2 to the power of 5, we write 2 minus 5, the exponents get subtracted. And then we use the second rule, which was power of power, they get multiplied. You see that? They get multiplied, and that is why we multiplied these two numbers. Minus times minus is plus, and 3 times 2 is 6. Perfect. And 2 to the power of 6 is indeed 64. Perfect. Right. So we have evaluated. In the similar fashion, can you do the next one? Let's try to do it. Now here we learn another strategy. So let me rewrite this as we have negative inside, right? And 3 to the power of 4 minus 5 means this. And then we have minus 1. So here we have minus 3 to the power of minus 1. Because 4 minus 5 is minus 1. And when you multiply this power minus, what happens? Well, minus and minus becomes plus 1. Okay. So that is what it is. And this exponent is also for negative. Minus 1 to the power of minus 1 is indeed negative number. So that is negative, right? And what we get here is 3 to the power of 1, which is indeed equal to minus 3. So we get minus 3 as the answer of this particular question. A bit tricky, right? So think about it and see, does it make sense? Perfect. So you might have to pause a bit or rewind and again check this result. Is it correct? Perfect. Okay. So you may have to look into this. If I have minus 1 to the power of 3, it is equal to minus 1. If I have minus 1 to the power of 4, which is even, that is plus 1. Do you see that? That is important. Any negative number to the power of even will make it positive, but if the exponent or the index is odd, then negative number remains negative. Important to understand, correct? So that's a big property which we have to take care of. And in this, you see I have minus a whole square written as positive a squared, right? Because it is 2, which is even, right? So let's look into this. This is even exponent. Makes sense? And this one is an odd exponent, like 3, 5, 7 and all, right? So it became negative. Perfect. So you have to take care of this while working on these examples. You see how one by one we are utilizing all our rules, right? And understanding the concepts. The last one here, we have a negative here and then everything to the power of 0. Remember this time, everything to the power of 0 will be what? Everything to the power of 0 will be just 1. But when you multiply by negative, we get negative 1 as the answer. Not just 1. You get the idea. You have to be careful. Now, it is not minus is not inside, right? It is outside. So, to the power of 0, 0 is only exponent for whatever is there inside the bracket. Make sense? Okay, great. So, this is, I will say, a tricky question, right? So, I'd like you to focus on this, understand these steps once again. It looks simple, but could be extremely tricky. Perfect? Okay, let's move on to another set of examples. So there are many of them for you. So in every example, we're trying to teach you new techniques. In the last example, what did you learn? We learned that if there is something like negative, then it's odd and even powers, right? And if it is inside or outside, it makes difference. Perfect. This time, we are again looking into powers of powers. So we are going to apply two rules. One, the quotient rule, and then the power rule, okay? So we have 3 to the power of 4 divided by 2 to the power of 5 to the power of minus 1. The question has changed. Now the question is, write with negative exponents. We do not have to evaluate this time. You get the idea? We have to write with negative exponents, correct? Earlier it was simplify and then evaluate. Do you see that word? Evaluate. It means find the value. Now here we have to only write as a negative exponent, right? When maintain exponent as negative. So let's go through this, right? So when you have power of power, they get multiplied. You know that, right? So if you have a to the power of m to the power of n, it is a to the power of mn. They get multiplied, right? So just multiply them. We get 3 to the power of minus 4. And here we get 2 to the power of minus 5. Do you see both are negative exponents? So that becomes our answer. Perfect. Next one for us is a squared divided by b cubed. So when the power is 2, we call it squared. You see that? Square and the term cube. So these are good terms to remember. So whenever we have like b cube, right? So we have b cube and a squared. You see that? So power of 2 is called square and power of 3 is called cube. Now minus 10 outside. So we'll multiply each with minus 10. So exponent 2 times minus 10 will become minus 20 and b times minus 10 becomes minus 30. So that is your answer. Do not do any other thing, right? We have written this as negative exponent. Makes sense? Next one here. Now, you see n to the power of 7 and n to the power of 2 written here. That could be simplified. Perfect. So we'll actually simplify and then write it as the negative exponent. So inside n to the power of 7 minus 2 and then we have m cubed, right? And to the power of minus 2. That basically becomes n to the power of 5 over m cubed and the power is minus 2. And when you multiply, we get n to the power of minus 10 over m to the power of minus 6. Make sense? You may have to simplify at times to get to the result. So these examples really teach you in a very simple basic steps how do we solve such questions. Are you there with me, right? It's pretty long so far, and if you're still there with me, there are many things to learn, and more than that, practice questions are coming your way. Perfect. Well, in case you want to learn from me, you can always send an email on this particular address, and there you will be on the success path. As you can see here, many students have performed so well that they are indeed on top of their class, getting more than 90% marks. Perfect. Okay, now we'll go to the last set of examples. This is mainly designed for you to answer. So in the first 4 sets of examples, what we learned is to be applied here by you. Correct? We've gone through 12 questions in first 4 sets of examples. Now these are next 3, which makes it 15 examples. Correct? So we have 15 examples here, right? Perfect. So here we have things like negative, which is inside the bracket in these 2 cases, and the exponents are even and odd. So you need to apply that rule. And in this case, the negative sign is outside the bracket. It is not affected by the index. You get the idea, right? So now, I'd like you to pause the video and answer these questions. And if you do them correctly, you are indeed ready for any test on this topic. Perfect. So let's begin. So the first one, negative, since the power is even, forget about that negative. First handle this. It becomes positive. So I'll go step by step and I will write this as 3 to the power of 4 over 2 to the power of 5 and to the power of minus 2. So I've taken care of minus 1 to the power of minus 2, right? So I'm saying minus 1 to the power of minus 2 is just plus 1. And so I have dropped the sign which was here. Makes sense, right? Okay. Now I'm going to multiply, apply the rule. So we have 3 to the power of minus 8 over 2 to the power of minus 10. So we have now got the negative exponents. What is the question? Well, let's look into the question. Write with positive exponents. Oh my God. This time, how do I write them with positive exponents? What I did was I multiplied and I got negative exponents. Well, you know negative is reciprocal. We can flip it, right? We can flip it. And therefore, this indeed becomes 2 to the power of 10 over 3 to the power of 8. Does it make sense to you? So we have to flip it to write this as positive exponent. Make sense? Correct? Now, I did it later, but you could have started with that because indeed we need positive exponents, right? So, okay, so let's do it for the next one. Now, in this case, minus and the power is odd. So, what should you do? Well, I will get a negative result. So, I'll put negative outside and within that, I'll just write what was given to us. So, in the first step, I have only taken care of this negative. It is such an important thing, right? You should give a priority to it. Now, this negative power indeed could flip it. So we will write this as b cubed over a squared, and we could write this as a power of 3. So this time I have adopted a different strategy. I have taken care of this negative, right? Do you see that? So minus 3, that negative flipped the number. And then we have cube. And this time, if I open it, what do I get? I get negative of 3 times 3 is 9 and 3 times 2 is 6. Make sense? So you could use any of these approaches. So this is alternate method. It's good to know this method because there are situations where this method may be applied. Okay? Like here, you found it simpler, right? Now let's do the last one here, which indeed is what? Negative is outside, so it just remains. And this negative, since we want positive exponents, I'll prefer to flip it to take care of the negative. Do you see that? So I'm going to adopt my second approach, which indeed is very effective in this case. So we get n, well, I was in a rush. We have 7 and 2. So that means what? Let us simplify this. So n to the power of 7 minus 2. That becomes in the numerator. And then we have m cube here. N to the power of minus 2. Makes sense? Okay, that's still positive. So I could write this as n to the power of 5 over m cube to the power of minus 2. And now I can flip. Right, so now I can flip and then write down this as minus. And when I flip it, I take it as 2. So we have m cube over n to the power of 5 to the power of 2. Right, the last step here is to multiply these things, but we know all are positive. And therefore, we get negative, negative, and we have m to the power of 6 over n to the power of 10. We got a result. Do you see that? Many steps to follow. So as we move along, these things could be very complicated. You get the idea, right? So with that in mind, now I would like you to go through the worksheet questions. I hope you enjoyed this set of examples and follow me on the YouTube channel or learn from me by sending an email and be on this success road with us. Perfect. So this is one set of questions for you. Very simple this time. Like our example where we'll just simplify and then evaluate, right? So many questions are given to you here. So normally we are placing 3 times 4, 12 questions in each. And this time we have 6 questions for you. But here we have expressions. Do you see that? We have to simplify each expression rather than working with numbers. At present, working with expressions could be complicated, but really, this is what you should be doing. And then you have to write them with positive exponents. You remember that part, not negative, but positive exponents, as we had in one set of examples. And this time, we have mixed up, and we want negative exponents in our answer. Does it make sense to you? Correct? So, try these questions and write your answers or suggestions in the comments. Perfect. I do have a solution set also, but at present I'm only sharing with you solution set for the first practice questions, which were 12 of them for you. Perfect. So that brings us back to this topic. So here are 3 bonus questions, right? So this is what I call bonus. So with these questions, you may write with negative exponents or with positive exponents, or you could also at times give some value to x and y and evaluate. You get the idea. So in this case, you can say x is equals to minus 2 and y is equal to 3. And then evaluate your answer. You get the idea. You could use these values in the next example also. So that gives you more practice on such type of questions, and it really helps you to understand how do we master this particular topic. So I hope you understand one thing, what and how the negative exponents and reciprocals are related. If the exponent is negative, then it really becomes a reciprocal, as you have seen here. Perfect. So with that, we end our video, and I hope you understand and appreciate it. Feel free to write your comments and your suggestions. If you like and subscribe to my videos, that would be great. And if you want to really learn from me, follow the success path, then send an email. Thank you and all the best.